All right, this is assignment number 1, and we're just going to practice evaluating limits and looking at them numerically, graphically, analytically. First part says complete the table, use the result to estimate the limit, use a graphing utility to graph the function to confirm your result. So I know that we used graphing calculators in pre-calc last year. So part of this, I want you to do the table just so that you are practiced at like entering stuff into Desmos if you're not as familiar with that. I would, instead of just, you don't want to necessarily type in this limit notation, but instead of just typing in this function, I'm going to call it f of x because I want to evaluate it at different x values. So I'm going to go ahead and say f of x equals, hit the divided sign, and then type in my stuff. Desmos, once you get used to it, a lot easier to enter stuff in. You don't have a million parentheses to worry about like we did with the TIs. So here's f of x. To fill out this table to start, I want to find f of 3.9, and I can write these numbers down. So I'm going to take this to about 3, maybe 4 decimal places. I'll just put like a dot, dot, dot. And so all we're doing here is adding some 9s. So then that adjusts things. So 0.2004-ish. Add an extra 9. So it looks like it's approaching 0.2. Let's see what it's like on the other side. What if we plug in, this is kind of annoying with my screen flipped. What if we plug in 4.001? Oh, put a decimal point in there. Okay, so even though this rounds, I'm going to just do this because we're just sort of analyzing this. So the 2 points that are closest to 4, you're getting awfully close to 0.2. And then as you get a bit farther away, we stray farther away from this again. So 0.1996. And it's kind of silly to go in the opposite order like this, but it's silly to be going farther from the point you're trying to evaluate, but we get the idea. So what I'm supposed to do numerically is estimate the limit. So I am estimating, based on these numbers, that the limit as x approaches 4 of, let's just say f of x here, is equal to 0.2, because it seems like as I add more decimals to get me closer and closer to f of 4, it seems like that's what we're plugging in. Now, if we were to factor and simplify this, I think we would get 0.2 or 1/5 as our answer. What's happening numerically? So let's take a look at this graph here. We are zooming in at 4. So at 4, we know that the graph is undefined, but we can see that, yeah, as we get closer and closer on either side, there it is. See how it says 0.2? So we are getting closer to 0.2 as we get closer on either side. So I'm estimating this to be the value, even though f of 4 is a hole in the graph. It's non-existent. All right, let's change this to, switch this around to type. So let's change this to sine x over x. Now, I can't see the graph right now. If you are having trouble seeing the graph and zooming out isn't working very quickly, remember you can, we did do this a bit in pre-calc. You can type in the value that you're trying to look for. So f of 0, you can add a table to this, I should say, and you can put in a couple of values. F of 0 is undefined, so I'm not sure if this is going to work. It doesn't like that. Let's do like 1. Let's do like 0.1 and f of 0.1, and then we'll just zoom around that. So you can look at, that brings me to 0. So graphically, it looks like the limit as we approach 0, even though f of 0 is undefined, looks like the limit is 1. And we should find that, I don't need this anymore, we should find that if we start evaluating as well. So f of negative 0.1 I'm just going to try to write this down with my screen open. So sorry if my handwriting's crazy. And then what if we make this 0.01? Well, that's getting awfully close to 1, right? And what if we add an extra 0 in there? Yep, even closer. And if we take off the negative sign, I'm going to stop filling in these numbers just because that's kind of tedious. You're not going to have to fill in a table for your AP exam. But the idea here is, yeah, look, as we get close on either side, this 0.9 gets closer to 0.9 repeating. This would round up to 1 if we were rounding to 3 places. So yes, my estimate numerically is that the limit as x, oh my goodness. The limit, let me flip my screen around, sorry. As x approaches 0 of this sine x over x, or of f of x, I believe that's equal to 1. And we can confirm that graphically, even though f of 0, is equal to no solution. So limits can exist. It's what is the intended value? What are you getting arbitrarily close to as you approach x equals 0 without actually saying the graph? The graph doesn't have to equal that number at 0. It just has to be close. All right. Use the graph to find the limit if it exists. So we don't need a graphing calculator for this part. If the limit does not exist, explain why. So remember, our 3 reasons were if the limit doesn't exist, maybe the left side doesn't reach the right side, or there's an unbounded region, or maybe some oscillation happening. So the limit as x approaches 1. So here's point here. The limit on the left is approaching the same y value as the limit on the right. And what is that y value? It looks like 1, 2, 3, 4. So that limit is equal to 4. The limit as x approaches 2. So here's 2. Now the limit is, if you're tracing the graph, what is the limiting value here? It's not about what the actual function value is. The graph is getting arbitrarily close to 2 without actually hitting 2. So this limit is equal to 2, even though f of 2 is equal to 0. This is really common on the AP exam, this next one. I'm sure we're going to have to evaluate this in a multiple choice. They won't give you the graph though, so you need to know if you have the same expression in absolute value divided by itself, and the absolute value can be on the top or the bottom. This is going to divide out to positive 1 if you're looking at x values that are to the right of what makes this 0 over 0. And then you would be looking at negative values if you're to the left, right? Because you would always get the same number divided by itself, or the same positive number divided by that number but negative. So this limit does not exist. I'm going to write DNE, does not exist, because the limit as x approaches 2 on the left of this expression is not equal to the limit as x approaches 2 on the right of this expression. Limit notation is important. This is most likely going to be multiple choice, so I guess that wouldn't matter. But if you do have to write something about this in a free response question, you have to have proper limit notation. So make sure that we're practicing that. The next limit is the limit as x approaches 5, which is the vertical asymptote here for 2 over x minus 5. Now, even though the graph on the left does not match the graph on the right, you can't use that as your reasoning because the limit on the left does not exist. It's going to negative infinity. And the limit on the right also does not exist. So we can't use the matching, the fact that they don't match. It would be this limit does not exist. And that's because 2 over x minus 5 is unbounded at x equals 5. There's a vertical asymptote. All right, the limit as x approaches 1 of sine of pi x. So here's x approaches 1. Looks like both sides of the graph, if you were to trace from either side, are approaching 0. So that's the answer to that limit. Oscillation, remember, is only when it looks like there's like a scribble going toward that value. And even if you zoom in, it still looks like a scribble. All right. Use the graph of the function to decide whether the value of the function of the given quantity exists. If it does, find it. If not, explain why. So first part is f of 1. So f of 1 is equal to this point right here. F of 1 is equal to 2. The limit as x approaches 1 of f of x. So remember, the limit is what is the graph approaching on the left and what is the graph approaching on the right. These are different values. The left-sided limit is looks like 3.5 maybe, and the right-sided limit is 1. So this does not exist. And because I don't have a ton of room right there, I'm going to put this down here. That's because, again, using my proper limit notation, the limit as x approaches 1 on the left of f of x is not equal to the limit as x approaches 1 on the right of f of x. All of this notation has to be correct. You need your which direction you're approaching, what you're approaching, and either left or right. You need a function right here and a not equal to sign in the middle. What is f of 4? F of 4 does not exist. There's a hole at x equals 4, and there's no point above or below it to say what the function value is. No solution, or it does not exist. I don't need to explain why for that one. I guess I could. There's a hole in the graph. And then what about the limit as x approaches 4? So as you're tracing the graph from either direction approaching 4, you are approaching the same value. It looks to be 2. So that limit is 2, even though f of 4 doesn't exist. All right, next one. Looking at this graph, f of negative 2. That's a vertical asymptote, so that's no solution. I'm just going to write VA, vertical asymptote. The limit as x approaches negative 2 of f of x does not exist. Again, it's not because the left does not equal the right, because neither of those limits exist on their own. They're both approaching infinity. So I would say f of x is unbounded at x equals negative 2. What's f of 0? So when you input 0, you get an output of 4. What's the limit as x approaches 0? This limit does not exist because the limit on the left looks to be about 1/2, and the limit on the right is 4. So it does not exist, and I'm going to take this out here. It's a good idea, even though this is tedious, it's a good idea to practice this because if you aren't used to writing out this limit notation, it can be hard to remember what to write and how it's supposed to be, but I think it helps just to write it out a few times on your homework. This is your first homework assignment, so you shouldn't be burnt out on writing everything quite yet. Okay, so first textbook assignment, I should say. So that's my official notation. What's f of 2? So when the input is 2, there's a hole in the graph. There's nothing above or below, so that is no solution. F of x doesn't exist at 2. What's the limit as x approaches 2 of f of x? So the graph on both sides is approaching the same y value. We're getting arbitrarily close to, we're just going to estimate this to be 1/2. I guess I can assume this is linear, so I guess I can do, the slope looks to be, I'm still estimating though, right? Because I don't have two distinct points on here, so I'm just going to go with 1/2. F of 4 looks to be 2. And the limit as x approaches 4. Now the graph on either side of 4 is going up to infinity. So even though those are going in the same direction, that still does not exist because the graph is unbounded. The graph is unbounded as x approaches 4 from either side. Even though f of 4 exists, the graph is heading toward infinity in both directions. And then all of a sudden it just jumps to 4. All right. For 31 and 32, sketch a graph of the function that satisfies the given value. So there are a lot of correct answers. I'm just going to talk through how I might draw this. So first off, I need to make sure f of 0 is undefined. So maybe I have an unbounded graph or a hole right here. I want to look at the other information. The limit as x approaches 0 is 4. So the graph needs to be approaching 4, but maybe there is a hole then if the limit exists. So I'm going to put a hole at 4. F of 2 is supposed to equal 6, so I'm going to plot that point for sure. And then the limit as x approaches 2, though, that's only 3. So So let's do this. I'm going to do so I'm going to put a hole at 3. And I'm going to say, okay, I've got some sort of some sort of a curve like this. I don't know if this is what I had in my original answer key or not. And then let's see, f of 0 is undefined. This limit exists. It's 4. This point exists here. Maybe I've got a line going that way. So the limit as I approach 2 is 3. However, f of 2 is 6. The limit as I approach 0 is 4. However, there's a hole there, so f of 0 is undefined. So I think that's a good example of a graph that could work here. Okay, what about the next one? It's a good idea to plot points if they're given right away. So f of -2 is 0, and f of 2 is 0 as well. The limit as x approaches -2 is 0, but the limit as x approaches 2 does not exist. So I need the graph to kind of pass through -2. And this limit does not exist, so maybe I can have a break in the limit. Like maybe I have a piecewise function like this. And so maybe this is the graph here. Oh, no, wait, that limit does not exist. Sorry. Maybe it's something like this. Again, this might not be the same as what I posted in my PDF key, but I've got the 2 points I need. This limit as we approach 2 does not exist because left doesn't equal right. That's the way I went. And this limit does exist, and it's 0 because my graph is passing right through that. All right, I left my screenshot up here. Use a graphing utility to graph this function. Estimate the limit if it exists. What is the domain of the function? Can you detect a possible error in determining domain of a function solely by analyzing the graph generated by a graphing utility? Write a short paragraph about the importance of examining a function analytically as well as graphically. Okay, let's go ahead and graph this thing. Even though I had a screenshot on there, let's just go ahead and graph it. So f of x equals, I put my division symbol in first. You can type in SQRT if you don't want to have to. I hate having to click down here and use this keyboard. So no, SQRT, x plus 5 minus 3 over x minus 4. All right, and we're looking at 4. So I'm just going to kind of scooch my graph over here. And now the nice thing in Desmos is this will tell you f of 4 is undefined. The graphing calculator, if you trace, it might show like a blank spot. But yeah, if I don't click on that, it looks like the graph is fully defined. It doesn't show like an open circle right here, even if we zoom in. So what can be misleading, and I wrote this in my paragraph here, what can be misleading is the graph doesn't show any interruptions or any holes. So we might think like, oh yeah, this value exists perfectly. The limit, it does help me with the limit in that case. I can say, get close to 4, and I can say like, what does this limit look like? It is like 0.1 and then 6 repeating. And so I can sort of analytically say like, oh, I don't know, is it 0.16666 if I keep defining things? Let's see, have we learned how to do analytic? No, I don't think we have yet. We haven't talked about what to do algebraically. For like, how am I going to find what this value is? So I'm going to actually save this for later, but I'm going to guess that it's 0.16 repeating. And I can do it for, let's see. I can do it analytically by saying, what's f of 3.99999? See how I keep adding 9s and it keeps getting me more like values. Oh, it's jumping me way up. So is it not 0.16? I don't know. Let's go on the other side. 4.01. And then let's add some more zeros in there. Jumping to 0.44. So, maybe it's 0.44. So if I analyze numerically, maybe this comes out to 0.44. We will have a way where we look at this limit and we rationalize the numerator, but I'm going to do that. I'm going to do that like later, I think in a day or two. So I don't want to get to this actual value, but this function definitely exists, and we can kind of estimate what we think that value that we're approaching is. More to come on this probably tomorrow. Okay, true or false? Let's see. Are we doing all of the true or false section? Let me take a look at my numbers. 71 to 74. Yeah. So if f is undefined at x equals c, then the limit of f of x as x approaches c does not exist. So let's see. Is this true or false? F is undefined at c. Does the limit not have to not exist? Undefined could mean whole or vertical asymptote. And we've been learning just because there is a hole at a point doesn't mean that the limit does not exist. So this is false. So here's my counter example. Here's a graph at C where there's a hole at C. So the limit exists. The limit as x approaches C of this f of x exists. It's just the function is not defined right there. If the limit of f of x as x approaches c is 0, limit is 0, then there must exist a number k such that f of k is less than 0.001. So let's see. So we know we have a graph where the limit as we approach c is 0. So that could mean that f of c equals 0, or that could be a graph like this. Could be a graph like this. And there could be a hole right here. So let's look through all those scenarios. Have we gotten away with getting close to 0 and not having a y value less than 0.001? All the negatives are less than 0.001. All the positives, as you get close to 0, you have to get very close to 0.001. So I think that's got to be true. If you have a graph that the limit, so the graph is getting arbitrarily close to 0, it's got to get less than 0.001 at some point because you're getting closer and closer to 0. 73. If f of c is equal to L, then the limit as x approaches c of f of x is equal to L. So that's false. Because let's go with my counter example again. So this limit is equal to L, but, f of c is equal to L. Let's put L up here. I read it wrong. But the limit is equal to k. So that's a scenario where just because a function value is one thing doesn't mean the limit has to match. And I think what I was just illustrating is the reverse of that. So just because the limit is equal to L doesn't mean the function value is equal to L. So same thing. That's false for a similar reason. So switch that. I could say, okay, this is the function limit is L, but the function value is k. They don't have to be the same thing. All right, that finishes this first homework assignment. Please come into office hours early or ask about any of these in class if something didn't quite make sense, or if you caught one of my mistakes, by all means. I will make mistakes this year, so please bring those up so we can discuss as a class and I can correct things.